Let's have a look at problem 1944, number of visible people in a queue. Actually, we have just practiced problem 2282, so I will see now this problem becomes easier. So for this problem, we're going to share a monotonic stack solution. So here we are using decreasing stack. So first I'll walk through the statement of the problem and then emphasize one of the constraints. And then we will explain the idea and the intuition and the specific procedure. And finally, we share the code, explain the code, and do the tests. So first, let's look at the statement of the problem. So there are n people standing in a queue, and they are numbered from 0 to n-1 in left to right order. So we are given an array of heights of distinct integers. So here is distinct, where height I represents the height of the ith person. So a person can see another person to their right in the queue if everybody in between is shorter than both of them. So this is the definition. So now we are required to return an array called answer of length n, where the ith element is the number of people the ith person can see to the right in the queue. So below it's a beautiful explanation of this problem. So here in example 1 we have height which given by 10, 6, 8, 5, 11, and then none. So for example, the first person, index 0, has height 10. It can see 6, can see 8, can also see 11, right? So here is a 3. So similarly, we can interpret other elements in the output. So in example 2, so we see the first people, that's the 5, can see 1, can see 2, can see 3, can see 10. So that's the 4. So let's look at the constraint. First, the height has a length n. N can be up to a order 10 to the power 5th, which is very long. So we cannot resort to purely brute force. So the last one actually is very important. So if we have practiced the problem 2282, in problem 2282, there's no such an assumption as the heights are unique, right? So with that said, let's look at the idea and the solution. So the method we're going to use is called monotonic stack, and here we're going to use a decreasing stack. So the idea is simple, just we think a little bit differently. So we think in the reverse direction. So as this, at each index I, we see to the left. What we want to examine is that which persons before or left can see I. Let me just do the corresponding update. That's about it. So, but one point to notice is that we shall avoid doing purely a brute force traversal from the beginning to I. If we do such a way, so this does not take advantage of the problem assumption. So in other words, the definition of a person can see another person. So here actually naturally comes the familiar monotonic decreasing stack. So the procedure is as follows. We will not run the code in a verbose fashion. Let's just establish the intuition. Then we will explain the procedure during we do the code. So for example, this is the height. This example actually I copied from problem 2282. So you can try it for this example. So the height is 31425. So if we look at initially, let's initialize this all by zeros. So here I'm writing the final state. So let's do the initialization. Then we examine index 0. So index 0, there's no people left to the edge, so we do nothing. And then we look at index 1. So index 1, the people left that is 3, can see this guy. So we update that by 1. Then we look at the index 2. The height is 4. So 1 can see 4. So we update by 1. And 3 can also see 4. So we update this guy by 2. By 1. That is 2. So now let's look at the index 3. This is 2. So 4 can see this 2. So we update this by 1. But people left to 4 cannot see 2 because they are all blocked by 4. So we have 1. So now let's look at index 4. That is 5. 2 can see 5. We're going to update by 1. And 4 can also see 5, right? So we are going to update it by 1 again. So what we get is a final state 2, 1, 2, 1, 0. The rightmost people always can see nobody because there's no people to the right, to the right of that person. So that's the intuition. But we are in the manually check, we just do from the right to left. So in practice, this is a simulation of the standard decreasing stack. So we shall use the decreasing stack to aid the above procedure. So in the stack, essentially we are looking at the height, but we need to store the ID in order to do the update at the correct position. So with that said, here we would like to raise some questions that may be helpful to understand the code. So in this problem, there's an assumption which says that all the values of height are unique. So that actually simplifies the problem a little bit. So the first challenge is that what if the problem allows values of height are not unique? So second challenge is, can we try walking through the example below by both intuition and by following the code we are going to share for example 1 here. Thirdly, can we write a solution to Leetcode 2282 starting from here? So yeah, that's about it. So now let's work on the code and explain the logics in between. So if we have solved problem 2282, so this problem then is easy now. So first I'm going to make some preparation. So for this, I first track the length of this height. Let's call height just for convenience. Then also I'll initialize a list which I'm going to return its final state. And then let's not forget to instantiate a stack, so to mimic the process. So now we do the genuine work, so iterate. So when we do the reiterate, so we will explain why we are going to use decreasing stack. So first, for I in range n, which corresponding in our idea that at each index we examine which person before or left can see her or him. So now we are going to first examine in the current state if there are some short guys, so that they can still see this current person. So we are going to do the while loop, while stack, and the height of the stack top, the stack -1, is less than the height at current index. So if this were the case, we're going to pop until we match people no short than the current height. So that's why we are going to, the stack is going to be a decreasing stack. So with that said, we're going to pop this one, stack pop. This means that the people at index j can see people I. So we are going to update the result for people j by 1 because it can see a new person, that is I. So with that said, after the while loop, we're going to check if the stack is empty or not. So if stack is not empty, then what we are going to do, we are going to, because this guy is going to be larger than the current height due to the problem assumption and the while loop, we're going to update this one, stack -1, increment by 1 again. So that's the case. So after all, so at the very beginning, for example, when I equals 0, the stack is empty, so we didn't enter this loop or enter this if condition. So we are going to put or push that index to the stack append I. So that's about the procedure. So now with that said, we are going to return the result. So yeah, that's about the code. Let's first review the structure. So first, we are making some preparations in order to run our idea or procedure. And secondly, we do the thing. The thing is that at each index, we are going to check the people to the left. So we find those that can see the current person I. Then we'll update the corresponding count of people that person CG can see. With that said, we're going to test the special cases first. So it passes the first one. Now let's look at the second one. Oh yeah, it passes the second one. So the length can be 1. So let's just try 1. So this should return 0 because no people to the right. So let's say yeah. So with that examined, let's check the generic case. Yeah, it passes the generic case. So here, actually, this is almost the end of this this solution. But now let me focus on one more thing, just this one. So all the values of height are unique. What are not unique? So actually, if the height can be equal, so we should update the index in here. So so let's do that. So here, if we are here, basically, what we want to do is make a comment if heights are not unique. It can be. It means it can be equal, right? So if this is the case, we need to update the result a little bit. So just a simple, like in problem 2282, heights. I'm going to stack -1 if it equals the current height. Then what does it mean? It means that the people left to the stack -1 cannot see current people I and the people to the right because this is equal, it's blocked. So what we are going to do is that we're going to update stack -1 to be the current index, so that when we check for a new people comes, we just need to check from stack -1 to up to I, save a lot of operations. So with that said, we can actually test for all the cases. It should pass. The reason is that we add more logic here, right? Solve this problem more thoroughly in view of this specific constraint. So it's a demonstration that this constraint plays a role in the format or representation of code or solution. So that's about it. Thank you.